In this video, I am going to discuss general pivot point scaling. Before we discuss the topic, let's try to understand what is translation. So, this is the y-axis and this is the x-axis. Here we have the origin. Let's consider the point with coordinates x comma y. This point is moved along the positive direction of x-axis by an amount of tx and along the positive direction of y-axis by an amount of ty. Then we get this point. Say its coordinates are x1 comma y1. We can write down x1 equals x plus tx, y1 equals y plus ty. Now, if we represent this point using a matrix, it is something like this. We can use a 3 cross 1 matrix. Now, we can represent this point using this matrix. We have to find a matrix. When we multiply these two matrices, we get this one. So, in order to be able to multiply these two matrices, the type of this matrix must be something cross 3. Number of rows in this matrix is 3, therefore, here it must be 3. This is a 3 cross 3 matrix. Now here this one x1 means x plus tx, y1 means y plus ty, here 1. Now, in order to get this term x plus tx here, first row 1 into x, we get x. There are no y terms, therefore here it should be 0 into y, finally here tx. So if we multiply first row by first column, you get x plus tx, this one. So second row, we do not have x terms, therefore here it is 0, y terms 1 y, then here it should be ty, y plus ty. Now finally, in order to get 1 0 0 1, then we get 0 plus 0 plus 1, we get this. Now this matrix, we call this the translation matrix. That means it transforms this particular matrix to this one. So we represent this using capital T, Tx, comma Ty. So now this point, if this point moves to this position like this, this transformation, we call this transformation as a translation, and this is the corresponding matrix for translation. Now let's look at scaling. This is y-axis and this is x-axis. Here we have the origin. Let's consider a point with coordinates x, y. Then we get x1 sx into x, y1 sy into y. So sx and sy are called scaling factors. So let's say here we have x1 y1. Now if we represent this point using a matrix, it is like this, and if we represent this point, it is like this. Now we have to find a matrix such that multiplication of these two matrices gives this matrix. Now in order to be able to multiply these two matrices, the type should be something cross 3. Number of rows in this matrix is 3, therefore here it must be 3. Now this one we can write x1 means sx into x, y1 means sy into y, here 1. Now in this matrix we put sx 0 0, then we can get this term sx into x 0 0. Then in order to get this 0 sy 0 0 0 1. This matrix, we call this matrix as the scaling matrix, and we write it like this: capital S, simple sx, simple sy. Now this matrix can transform this matrix to this one. Here now this point moves to here. So this transformation, we call this transformation as scaling, and this is the corresponding matrix. Now let's discuss our topic, general pivot point scaling. We have y-axis and x-axis. Here we have the origin. Now let's consider this point and its coordinates are x0, y0. Now we have a point. If you remind the earlier scaling matrix, it is like this: Sx 0 0 0 Sy 0 0 0 1. So if we apply this to a point, then we apply this to a matrix that represents a point. So now we will get Sxx Sy y 1. Now this matrix actually scaling is performed with respect to the origin, because x coordinate is multiplied by Sx and y coordinate is multiplied by Sy. Now general pivot point scaling means now we have a point, general point, not the origin. So we should find a matrix that can be used to scale this point with respect to this point. So now we are going to try to use this matrix. So first we have this point 3 cross 1. We apply translation matrix 1 0 minus x 0 0 1 y minus y 0 0 0 1. We apply this translation matrix. So let's think. Here we have x naught, y naught. Then what happens? Multiplication of these two will give us 0 0 1, 3 cross 1. This matrix represents the origin. That means if we apply this translation matrix to the matrix that represents this point, it will come to the origin. Now, what happens if we apply the same matrix to this one? That means to the matrix that represents this point. So if it was this point, it will come to the origin. This will come to the origin. Then if we apply the same matrix to this one, what happens? Same translation we perform. Same amount along the positive direction of x-axis and same amount along the positive direction of y-axis. Therefore, this point will come to here, this point then will come to somewhere here. Let's say this is our position 1, and now we can compute coordinates of this point. It is a 3 cross 1 matrix, and this is our point 1. Now we can scale with respect to the origin. This one, this point we scale now with respect to the origin. Sx 0 0 0 sy 0 0 0 1. So we use Sx and Sy scaling factors. So let's think we get this point and its coordinates. Now we have translated to the origin and scaled it. Again, what we have to do? Again, we have to do the reverse process. We use this translation matrix 0 1 y 0 0 0 1. If we apply this translation matrix to the origin, it will move to here. Now we are going to apply this to this. So we translate with the same amounts. So here this point will come to somewhere here. And this is point 3. So let's take this as x1, y1, 1, 3 cross 1. So this is our x1, y1. if we multiply these three matrices, you can get this matrix. That means this matrix is transformed to this one using this matrix. So this is the composite transformation matrix for general pivot point scaling. So that means if we scale this point with scaling factors Sx and Sy with respect to this point, then we get, let's say we get this point. Therefore, this transformation we can do using this matrix. So this is what we mean by general pivot point scaling. I hope you could understand well. So thank you for watching.